Hi Algebra students, welcome to the factoring unit. So likely this is your second unit in the Algebra 1B section of the class. And so we've just finished up polynomials, and so we're going to do a bit of review about that, and then we're going to kind of go backwards to do some factoring. So here at the warm-up, these should be things you know how to do. We're just going to be distributing, multiplying that monomial on the outside times each term inside, and keeping in mind our exponent rules. So a times 3a, we should know is 3a squared, and a times 7, 7a. Negative 2m times m squared, negative 2m cubed, negative 12m squared, plus 2m. Hopefully none of this is confusing to you, because this is what we should have just finished. For x to the fifth, notice I'm adding those exponents. Doesn't matter that the one inside didn't have a y. And then negative 2 times 4, negative 8, still x to the third, but y is now squared on that second term. So when we talk about factoring, we are going to be writing a polynomial sorry about that, as a product so we're going to be writing it as a product. So in other words, we're going to be writing it in what we call factors. Factors are the things that multiply together to get a product. So simplest form, for just a very simple example, simplest form would be something like 3x plus 12. Factored form would be with the 3 on the outside, and then x plus 4 inside parentheses. So we're writing it as a product of two things, a product of the 3 and the x plus 4. If something cannot be factored, we say that it is prime. Like prime numbers can't be factored into smaller numbers. So what we use to factor is going to depend on the polynomial, how many terms it has, what degree it is, all of those things. But we're going to start by finding and factoring out the greatest common factor. And if you took Math Foundations at the Excel Center, you learned about greatest common factor, because you did that just with constants, with the coefficients in this case. So we will still be thinking of that same thing with the coefficients. What's the largest number that divides into both, or all three? And then also looking at the variables. For a variable to be part of the greatest common factor, or GCF, it has to be in all of the terms. If it is in all of the terms, you take the smallest exponent, because that's what they all have in common. For instance, if I have 3 brothers and Sue has 2 brothers and Jim has 5 brothers, we all have in common that we have at least 2 brothers. So we go with the smallest number, even though it's called greatest common factor. It's because we're going to take out as much as we can that we can divide out of everything. So our previous division work is going to be important. Some of these will be more obvious because they may only have a coefficient as a common factor or a constant. So here we are in number 1. This is like the example that I used up top, coincidentally or subconsciously. So what do they both have in common? They both have a 3 in common. That 3 is the GCF, and then to find what's left in the parentheses, I'm dividing each term by the 3. Now, for a problem as obvious as that, you may not need to write this part that I put underneath, but for some, you might find that that's helpful. Go ahead and take a moment, pause me, try number 2. All right, did you try it? Hopefully so. They, of course, have a 7 in common. Notice what happens. You cannot just put a 7 and then put y. So 7 divided by 7 is not 0, it's 1. So we need that 1 there. We should be able to check problems that we factor with greatest common factor by distributing. So if I distribute it, I should be able to get back to my original. There also should never be anything still in common between the terms that are in the parentheses. If there is, that means you did not take out the greatest common factor. Maybe you took out a common factor, but not the greatest. But it is important, if we start out with a binomial, we will have a binomial inside the parentheses when we're factoring with greatest common factor. So they could both have a variable, but if that variable is not the same, then the only thing they can have in common is a coefficient or a constant. So I could divide 8 and 36 by 2, but that would not be the greatest number I can divide by. 4 would be the greatest. So 4 comes to the outside. Then to find out what's inside, whether I actually write it or I just do this mentally, I'm dividing both terms by 4. They both would still have the variable parts. Okay, so pause, try number 4. Did you actually pause or just keep going? So 5 on the outside, x plus 6y. So notice in both cases, inside the parentheses, there is nothing left in common. And if I distribute, I get back to my original expression. Now, when you're checking, don't get yourself in some vicious cycle where you distribute and then you factor and then you distribute and you factor, just check one time. But if you're factoring, then this is what your answer is going to look like for greatest common factor. So number 5, what goes into 6 and 27? Yes, indeed, 3. So I'm going to divide them both by 3. That gives me 2a squared plus 9. Again, nothing left in common inside. So those have only had constants or a coefficient with a common factor. Starting with number 6, now we can also remove a variable as a common factor. So both parts, the biggest number they can be divided by is 4. Both terms do have a y. The lowest exponent is just y. So 4y is the greatest common factor. That can come to the outside. And then remember from our dividing, by the way, when you're doing this, you never want to get a fraction. If you get a fraction when you do this division step to find out what's in the parentheses, it means that you tried to take out too much, or you're dividing incorrectly. So 4 divided by 4 is just 1. I don't have to write the 1 as a coefficient since there's going to be a y with it. And then there's an extra y. 24, negative 24 divided by 4 is negative 6. No extra y's. Done. And I kind of think of it like this one has 1 extra. That's why there's still a y left in the parenthesis. All right, let's skip down a little bit until we get to some of these with multiple variables. I'm going to go down to, I'm going to work through the left column, 9 through 15, perhaps. So here we go. Maybe, maybe not. All right, that's good enough. So for number 9, 15 and 30, yes, 5 goes into both of those, but 15 goes into 30, so you need to go that big. If you only did 5, you would end up inside with a 3 and a 6, and 3 and 6 still have something in common. So if that happens, you need to back up and take out more. So in this case, 15 goes into both. Do they both have an A? Ah, indeed they do. First power is the smallest though. Do they both have a B? Indeed they do. So 15AB is my greatest common factor. So both terms will get divided by that to find out what our other factor is inside the parenthesis. So 15 divided by 15 is 1, and then I still have A. Now, if 1 was the only thing, I would need to write it, because it can't just be empty. But there is an A, so I don't need to write 1A. I can just write A. And then negative 30 divided by 15 is negative 2, and the A's and the B's cancel, just like over here the B's canceled. If you distribute, you get back to the original. In number 11, there are no numbers, but both terms do have an A in common. So that is the greatest common factor. They do not both have a B, so B cannot come to the outside. When I divide both parts by A, I get B subtract 1. I do need the 1 there, otherwise I've lost my second term. So it started out as a binomial, so I have a binomial, 2 terms, inside the parentheses. Number 13, do 5 and 13 have anything in common factors? Only a 1. And we're not messing with dividing things by 1 because it just gives us the same thing. And they do not have a common variable. So this I could just rewrite the way it is. Typically what we will do is we will say it is prime. Okay? It's prime. It cannot factor any further than just how it is. It is what it is. Like a prime number like 2 or 3, can't break it down except for multiplying by 1. In number 15, we now have a trinomial. So now I have a trinomial, so anything that I want to put out for the GCF has to work for every single term, not just 2 of them. And so I see 2, 2, 4, so 2 does divide into everything. Do they all have an X? Indeed, but 2 of them only have first power, so I can only take out just 1 power of X. Do they all have a Y? Indeed they do. And then inside parentheses, this first term has an extra X. Everything got taken out, basically, factored out, except 1X. In the middle, still negative. Everything is gone, except a Y. And then the last one, 4 divided by 2 is positive 2, and both his X and Y are accounted for on the outside of the parenthesis. So this is very much like distributive property in reverse, and that's why you can check it by distributing. You always want to be taking out as much as possible, as big a numbers, as high a exponents, without creating any fractions. So for instance, in 14, I look at 18 and 48. Someone may say, well, I know that 3 goes into those, or I know that 2 goes into those. Well, yes, those are both true, but you would want to go with 6 because that's the largest, the greatest common factor for 18 and 48. So we would use 6. They both have A, they both have B, and then C, we can actually go second power because that is the lowest exponent. That is the greatest common factor, so now I'm dividing both parts by that. So 18 divided by 6 is 3, subtracting those exponents, so there's an extra A, no extra B's, no extra C's. Then I go to the second term, negative 48 divided by 6, negative 8, no extra A's, no extra B's, but there is an extra power of C. All right, if you want to take a moment to try some of the others currently on the screen, and I will fill those in so that you can check yourself. Okay, also I'll unintentionally erase the other ones, but you can always rewind, back up, whatever, to see those if you need to. I don't think 10 and 12 probably give you much trouble. In 16, notice that I only could put an R on the outside as a greatest common factor. S was not able to go to the outside because the first term doesn't have any S's. Remember, it has to be in common with all three terms. So even though that first term has lots of R's, it doesn't have any S's. And then also keep in mind it is only R to the first power because the third term, that second power, is only applying to the S. All right, hopefully that was all helpful. Okay, a couple more at the bottom of the page, and then that should be sufficient examples for you to then be able to work on homework 1. So here, let me tackle a couple of these longer ones. So 23, 35, 20, and 15. 5 can go into all of those. That would be their greatest common factor as far as those coefficients. Then do they all have an A? Yes, they do. Lowest power is just 1. Do they all have a B? They do not. So no B in the greatest common factor. Let's divide them all then by 5A. So again, whether you do this in your head or you write it, if you find you're making mistakes, it may help to write it underneath each one. Sometimes people just write it once underneath the whole thing to remind them they're dividing. Whatever worked for you in dividing will probably work for you with this. So then 35 divided by 5 is 7. 1A left over. Negative 20 divided by 5 is negative 4. No A's, but B squared is still there. 15 divided by 5 is 3. No A's or B's, which is good because they should not all have something in common. Keep in mind it is okay if 2 of them would have A's, but if all 3 of them still had something in common, then we didn't take out a greatest common factor. Speaking of greatest common factors, we've got lots going on in number 24. We have 3 variables to keep track of, plus our coefficients. So for our coefficients, it's always worth a try to see if that smallest number would happen to divide into everything. And in this case, 3 does divide into 9 and 15. So we can use the 3. Do they all have an A? Yes, they do. Lowest exponent, just A to the first. Do they all have a B? Yes, they do. Lowest exponent, second. Do they all have a C? Yes, they do. Lowest exponent, just C. So now, this is what we're dividing everything by. 3AB squared C. So, 3 divided by 3 is 1. Unless there was nothing else left, I don't need to write that 1. And then there's A to the second, no extra B's, no extra C's. Go to the middle. Negative 9 divided by 3 is negative 3. I've got 1 extra A, 1 extra B, and 1 extra C, right? 2 take away 1, 3 take away 2, 2 take away 1 on the C's for those exponents. 15 divided by 3, positive 5. A's would cancel out. B's, 4 take away 2 is 2. C's, 3 take away 1 is C squared. Close up the parenthesis. And then remember, any of these, if you distribute, you should get back to the original problem. So let's say I wanted to check number 23. 5 times 7, 35. Add the exponents. 5 times negative 4, negative 20. A and B would just get written next to each other and keep the same exponents, and then 3 times 5, 15, and there's an A. And then other than the fact that page 2 is in the way, that matches up. All right, so that was greatest common factor. And if you were good with division, this should not be an issue. Good luck.